This presentation will introduce a very concept in hypothesis testing, type 1 and type 2 errors. Although there is very little computation to do around this concept, mastering the idea of type 1 and type 2 errors is fundamental to your understanding of statistics. In hypothesis testing, we are always conscious that there is some chance of an error, that our final yes or no will be incorrect. Let's take a closer look of the 4 different outcomes we can get by performing hypothesis test. 2 out of 4 outcomes are desirable, that is when the null is false, we reject the null, or when the null is true, we fail to reject the null. The remaining 2 outcomes are not so desirable. The first one is when the null is true, but we end up rejecting it, or when the null is false, but we fail to reject the null. They are known as type 1 and type 2 errors, respectively. Statisticians choose to see every choice as one between action and inaction. A type 1 error is a sin of commission, making a conclusion or taking an action when it is not justified. In statistical terms, we commit a type 1 error when we reject a true null. A type 2 error is a sin of omission. It is a failing to act or make a conclusion when an action or conclusion is called for. In statistical terms, a type 2 error is fail to reject a false null. Let's use this week's example 1 to demonstrate these 2 errors and their relationship. We performed a lower tail test in example 1, and the critical value is going to be on the left-hand side of the curve for a lower tail test. We would have to reject a null whenever the test statistic from the data is on the left-hand side of the critical value. If the null is true in reality, we would still reject it whenever the test statistic lies on the left-hand side of the critical value. We are making a sin of commission, taking an action that is to reject the null when it is not justified, because the null is true. Type 1 error happens for the lower-tailed corners of the curve, and the probability of making type 1 error is actually the significance level alpha we have discussed before. When we work on a problem when alpha is given to be 5%, this actually means that we are allowed to make a type 1 error up to 5% of the time. Type 2 errors happen for the false null. We have to assume that the null is false, meaning that alternative is true. The bell curve presented here is actually different from the previous bell curve. Its center is on the left-hand side of the previous one. We also draw a vertical line representing the critical value here. We have already discussed that we reject the null whenever the test statistic is on the left-hand side of the critical value, and we fail to reject the null if the test statistic is on the right-hand side of the critical value. If the null is false in reality, we would fail to reject it whenever the test statistic lies on the right-hand side of the critical value. We are making a sin of omission, failing to act, that is fail to reject the null when an action or a conclusion is called for, because the null is false. The probability of type 2 errors is the upper-tailed area for this lower-tailed test, and is usually called beta. I also placed the 2 plots on top of each other to let you see the connection between these 2 sources of errors. Every single error can be conceptualized as either a type 1 or type 2 error, and it is also inevitable to make a type 1 or type 2 error. Type 1 and type 2 errors can be summarized again in the following table. Many textbooks like to discuss these errors using the American system of criminal justice, which is innocent until proven guilty.